Transformations of sine and cosine. The graph of a sine or cosine wave can be transformed by either shifting, stretching, shrinking, or reflection. The elementary transformations of a sine and cosine wave are captured in function notation as follows. Translation. Shifting up or down is going to be plus k, sine x plus k, or cosine x plus k. Shifting left or right will have a minus h in the parentheses. Distortion. Stretching or shrinking vertically will be a constant out front multiplied to the function. Stretching or shrinking horizontally will be a constant that's inside multiplied to x. Reflection over the x-axis will be negative sine of x or negative cosine of x, and over the y-axis we'll have the negative sign inside the parentheses. Shifting the graph of a function sine x up or down is given by sine x plus k and is called a vertical translation. If k is greater than 0, then the graph of sine x shifts up k units. If k is less than 0, then the graph of f of x shifts down k units. Consider f of x equals sine x, here in red, two of its translations. Here is sine x plus 2, and here is sine x minus 3. The graph g is the result when sine x moves up 2 units, and the graph h is the result when sine of x moves down 3 units. Use the function f of x equals cosine x for each problem below. Write a rule or formula for the new function after the given translation. Shift the graph up or down k units as described. We'll shift it up 2 units, so we'll move k to 2. And that creates g of x equals cosine x plus 2. If we move it down 1 unit from here, so move it down 1 unit, we get h of x equals cosine x minus 1. If we move it down 3 units from the x-axis, we get this graph here, and that's cosine x minus 3. And then if we move this back up to here and then move it up 1 unit, we get cosine x plus 1. To review, if we move it up 2 units, we get cosine x plus 2. Moving the graph down 1 unit creates h of x equals cosine x minus 1. A k value of negative 3 moves the graph down 3 units, and we have g of x equals cosine x minus 3. And here we've moved the graph up 1 unit, and we have h of x equals cosine x plus 1. The grid looks like an ice cube tray. Move the 4 pieces from the left to fill 4 small rectangles strategically to create these 2 functions. So first we're going to have sine x plus 2. What I'm going to do first is just draw out sine x, the parent function, the basic sine x graph, and there we go. All right, and then sine x plus 2, we'll just take each piece, 1, 2, and move them up 2. 1, 2, 1, 2, and 1, 2. So this is sine x plus 2. Now for cosine x minus 1, first thing I'm going to do is create the cosine x wave. So I'm going to take this piece, move it there, this piece goes there, this piece is there, and this piece ends it like that. Now minus 1. So we take each piece and move it down 1. And there we have cosine x minus 1. Here is sine x plus 2, and here is cosine x minus 1. Shifting the graph of a cosine wave left or right is given by cosine of x minus h and is called a horizontal translation. If h is greater than 0, then the graph will shift right h units. If h is less than 0, then the graph will shift left h units. So here, in blue, we've shifted to the right by pi over 4. Because pi over 4 is h equals positive pi over 4, which is why it says x minus that, because here it says x minus h. Therefore, we move to the right pi over 4. Here we have pi over 2. So that means that h equals negative pi over 2, and the negative signs cancel out, giving us this plus sign here. Therefore, the green graph moves to the left by pi over 2 units. Use the function f of x equals cosine x for each problem below. Write a rule or formula for the new function g after the given translation. Shift the blue graph left or right as described. All right, we want to shift the graph right pi over 2 units. So we have g of x equals cosine of x. So we want to move right pi over 2 units, so minus pi over 2. And here you can see we've now shifted the graph over by pi over 2 units. For b, we want to shift the graph left by negative pi, so we have h of x equals cosine x plus pi. Since remember, it's x minus h, and this h value is negative pi, so we have x minus negative pi, which becomes x plus pi. Alright, so here in blue, we have g of x equals cosine of x plus pi, and we've moved to the left pi units. Next, we're going to move left negative pi over 4 units, so we have our new function is going to be cosine of x plus pi over 4, and this will move us to the left pi over 4 units. So here in blue, we have cosine of x plus pi over 4, so just a small translation to the left. Finally, we want to shift the graph right 3 pi over 4 units, so we'll have cosine of x minus 3 pi over 4. And here in blue, we have our newly shifted graph. Let f of x equal sine x. Its graph is displayed. The function g is given by g of x equals sine of x plus pi. Carefully sketch the graph of g of x on the grid below. Label a maximum point on the graph of g. Alright, so sine of x plus pi, it became x plus pi because originally it was sine of x minus negative pi. The h value is negative pi. So we're moving to the left pi units. So pi, as you can see here, is 2 boxes. So we take each point and move it to the left by 2. So this point moves to there, this point moves to there, this point moves there, and what other points do we have? This point moves there, so actually the zeros won't change, and we'll see what the graph looks like on the next slide. So as you can see, all of the zeros stayed in the exact same places, but now the maximums and minimums have swapped.